Hello, and welcome to this series of 505 XT steam turbine controller tutorials. In this tutorial, we will cover how to configure and run the Speed PID Optimizer routine. First, an overview of the test routine will be provided. Second, we will cover how to configure the test routine. Last, we will demonstrate how to run the test, interpret results, and accept the new dynamics in the control. The Speed PID Optimizer routine will automatically calculate your system dynamics and provide the following benefits: improved system response to disturbances, tighter control at the set point, and improved system diagnostics. We will first overview the optimization test sequence. The Speed PID Optimizer test routine allows the control to automatically analyze the system and calculate the P, I, and D terms for both offline and online dynamic settings. To calculate optimized system dynamics, small and progressively larger adjustments are made to the valve demand in order to measure the turbine system. The optimizer routine remains within user-specified process and valve movement limits to ensure that the turbine system remains within acceptable operating limits. The process of finding optimized system dynamics includes two modes. First, the analysis mode, and then the set point step mode. This trend provides an overview of the entire optimization routine. The actuator demand is given in yellow, speed set point in white, and speed in red. The left portion of the trend is the analysis mode. The right portion of the trend is the set point step mode. We will now cover how to configure and run the optimizer test from the panel of the 505XT. The test can be accessed from the Speed Dynamics Optimizer page. From the home screen, navigate to the Speed Control page and press Enter. On the Speed Control page, use the soft key menu to go to the Dynamics page. From the Dynamics page, press the PID Optimizer soft key to see the Speed Dynamics Optimizer page. To configure the test, press the Configure soft key to launch the pop-up menu. The default values should work for most systems without needing adjustments. However, we will cover each of these settings so that the test can be modified to meet the needs of your system. The process limit is the amount of movement allowed in the process signal during the test. If movement occurs during automatic tuning that exceeds this value, the automated test routine will abort and control at the initial set point. The limit is centered around the current process value at the time the test is enabled. For example, if the process limit is 2% and the speed signal is at 3600 RPM, then the upper movement limit is 3600 plus 2% of 3600, which equals 3672 RPMs. The lower movement limit is 3600 minus 2% of 3600, which equals 3538 RPMs. The online and offline actuator limits set how much the actuator demand will move during the analysis mode. The percentage will limit the output plus or minus from the actuator position when the optimizer test is enabled. The test will not abort if this limit is reached, but an alarm will be enunciated. It is important to note that the actuator limit is the most the actuator is allowed to move during the test, but may never reach this level. Because actuator movements start small and progressively increase, only the amount of the actuator needed to analyze the system is used. The Droop Limit limits the amount of droop signal movement allowed when using generator load droop. If movement occurs during automatic tuning that is more than this value, the automated test routine will be aborted and control at the initial set point. The response timeout in seconds determines how long the automated test routine will wait for a response after moving the actuator. The value should be at least 2 times longer than the system's slew and settling time. During the set point step mode, this value determines the step times and times between steps. A fault and abort will occur if the total test time exceeds a value of 40 times the response timeout. This PID type determines the mode of the PID controller. The fast-slow setting allows for the calculated system response to be more or less aggressive. If faster response time is needed, this value should be increased. If slower response time is needed, this value should be decreased. We will now overview the Speed Dynamics Optimizer page prior to enabling the test. The Speed Dynamics Optimizer page contains pertinent information while the test is running. In the top left of the page, the current speed and speed set point are shown. The two LEDs in the top right of the page indicate if a test is currently active. The OptiRatio active LED is illuminated when the OptiRatio test is active, which automatically tunes both the speed and extraction PIDs simultaneously. For more details on the OptiRatio analysis, please see the OptiRatio tutorial. Below the test active LEDs are the alarms and faults for the test. If a fault is given, the test immediately aborts and goes back to controlling the process at the current set point using the initial dynamics. An alarm will not abort the test and does not mean that the calculated gains are unreliable. Alarms are given to indicate response conditions that are less than ideal but might be acceptable. The user should monitor the system response to decide. Details for alarms and faults can be found in the Results Help pop-up screen, which can be used with the manual to help diagnose your system. Most of the time, an alarm or fault indicates a problem with the steam turbine system that is outside of the PID tuning. The PID Optimizer test can provide system diagnostics through the alarms and faults. Details for each alarm and fault, as well as a possible root cause, can be found in the product manual. Below the alarms and faults, the current values for the Speed PID output and valve positions are given. The gains table in the bottom right of the screen provides information on the initial system gains, as well as the calculated gains from the optimizer test. The offline and online LEDs indicate which set of gains will be calculated. The active LEDs indicate which gains are currently active. Prior to a test being enabled, the initial gains will be active. Once the test is enabled, the initial gains are active through the analysis mode. When the setpoint step mode is active, the calculated gains become active. The status LEDs on the left-hand side of the page indicate what part of the sequence the optimizer test is currently in. The completed LED indicates that the test was successful, and the Speed PID will continue to control at the initial setpoint with the newly calculated gains while the test is in the complete state. When the test is complete, the user can decide to accept or reject the calculated gains. If no decision is made, the test is automatically reset after a timeout period, and the gains will revert to the initial gains. The fault analysis aborted LED indicates that the test was disabled, and the Speed PID is controlling speed at the initial setpoint using the initial gains. The ready LED indicates that the test can be enabled. When the speed setpoint is moved, the ready LED will turn yellow and a message for settling will be displayed for 30 seconds after the setpoint is moved. This allows the system to stabilize prior to starting the test. When the ready LED is yellow and a message for high signal movement is given, it indicates that the test will likely fail due to the following: the system is unstable, or there is high signal noise on the speed signal. The signal noise must not be greater than 10% of the process or Droop Limit settings. When you are ready to run the test, open the Test menu from the soft key and press the Enable Test soft key. The test will begin and progress through the steps outlined above. At any point during the test can be aborted by pressing the Abort Test soft key. The Speed PID will immediately control the speed at the initial setpoint using the initial gains. When the test is complete, the Accept soft key becomes available. By pressing the Accept soft key, the calculated gains will overwrite the initial gains, and the test will reset using the new gains. To reject the calculated gains, press the Reset Test soft key, and the PID will revert back to the initial gains. You now understand how to configure and run the Speed PID Optimizer. Please be sure to view the other tutorials for more information.